here's what it looks like. And as you can see, just like Gilbert Ling was talking about, this is highly ordered. So the first criterion is satisfied, is met. I have two colleagues who told me independently that they repeated these experiments. I don't know that they published, and they concluded objectively that there really is something to it. And he'd focus his intention on it, and depending on the nature of that intention, and when he froze the water, the ice crystals would differ. If it was positive attention, he'd get beautiful ice crystals. If it was negative attention, you'd get ugly ice crystals. You can actually solidify this liquid crystalline water at room temperature. Now, imagine a kind of liquid substance that becomes a solid, just like ice, but at room temperature.
Could EZ water hold memory? Well, in this video, we're going to get into it. You're here with Mark Bowell and Jared Pollack on Perfect Gardens TV. Please remember to like, share, and subscribe. And if you haven't checked us out on Instagram and Facebook, make sure to do so. Don't forget about our $2.99 membership, because we have over 115 growers ready and willing to assist you through your growing practices. Let's go ahead and get into the video. Make sure to hit the join button on the bottom of every video.
And an issue that we address is, could EZ water contain information? And why this is important, potentially important, will become clear as I present. If we think about, could EZ water contain information, we look at a typical thumb drive, which contains information, right? The question I ask is, what are the main characteristics of this gadget? And does the EZ show similar characteristics, which would make it perhaps, shall we say, susceptible, amenable, whatever, to storing information? So what's inside of one of these thumb drives? Well, it's a bunch of transistors, each one made of silicon. And there are two essential features. One of them is that they're regularly arrayed in some planar fashion that sort of looks like this. That's the first characteristic. The second characteristic is that each transistor has two different states. You could call it 0 or 1 or on or off. And it's the fact that each one of these independently has not one state, but two states, plus the order that allows this to act as a memory to store information. Now, what about the EZ? Here's what it looks like. And as you can see, just like Gilbert Ling was talking about, this is highly ordered. Each plane is stacked upon another plane. So the first criterion is satisfied, is met. The second criterion is that one of these elements, either the oxygen or the hydrogen, has at least two states, or more than one state. Is that true? Well, it turns out, if you check any chemistry book, it will tell you that the oxygen actually has 5 oxidation states. -2, which we take as the valence of oxygen, is the most common one. It's the one we learn about. However, the chemists have found that it's not just -2. It could take on -1, 0, +1, +2. See, so it has 5 different states. So we conclude that, this has not only has the characteristics for containing information or memory, but it has it in spades, because this has 5 states instead of 2 states. And also, these atoms of oxygen and hydrogen, we're talking about the atomic scale, not the transistor scale, which means that the potential information density here is much higher than that in ordinary computer memory. We calculated, at least theoretically, the information density is something like theoretically 1 billion times higher than what now exists. So wow. It'd be a big leap if this actually turned out, the idea turned out to have practicality. You can imagine computer memories filled with EZ water rather than silicon transistors.
Well, okay. What you're describing here too is like you kind of pop, you're kind of mulling over an idea or something, and you're not sure what it is, and then the next day it pops in your brain.
where did that idea come from, and is it possibly being stored in the water and our molecules in out there in the ether? And that's something that I've heard many times, but that's kind of what I think when you talk right there in that moment.
Well, yeah, I mean, this is exactly, there are all kinds of subtle energies that exist out there. Nobody understands them, but it's clear that these so-called subtle energies or biofield, it's there, and somehow it impacts us. So if the two of us are sitting in the same room, you know, we're communicating by the usual means, visually, through sound and whatever. But there's also something subtle between us. You're sending messages that I receive, and people have referred to these as so-called subtle energies. And somehow, if they're transmitted from one to another, we must be receiving it. And many people now are of the opinion that the way this works is that it's absorbed by the water, and that the water somehow is absorbing information. I'll show you a couple of slides that speak to that issue. But this is an issue, I think, that's on the frontier, the scientific frontier, because right now so many people are coming to realize that this is something significant, that they're beginning to pay more attention to it. It's not yet mainstream, but it's getting close. Mm-hmm. So the person who is perhaps most famous for this is the late Masaru Emoto, who passed some years ago. And what he demonstrated is that if he put his intention to water, in other words, he focuses on the water, extending these so-called subtle energies to the water changes. And what he did was he'd take some petri dishes, little containers filled with water, and he'd focus his intention on it. And depending on the nature of that intention, when he froze the water, the ice crystals would differ. If it was positive attention, he'd get beautiful ice crystals. If it was negative attention, you'd get ugly ice crystals, and more to this. So, for example, here are some of his results. And in this case, here he played a Mozart symphony. Music also has an effect. And Imagine by John Lennon. You can see that when he froze the water to which the music was played, he got rather nice crystals. When he focused his intention on the water, thinking about peace, thinking about thank you, he also got beautiful crystals. But if he, I'm sorry, I don't know the translation. Somebody told me it's something like "you fool," but it's a negative emotion. Then this is what he got. And if he played heavy metal music, this is what he got. So these are sort of representative, but I got to tell you, they're not exactly representative, because what he would do is cherry picking. So he would play the Mozart symphony, and he'd have 50 petri dishes, and he would then freeze all 50, and he'd look at each one, and he'd pick out the one that he liked best to demonstrate the phenomenon. And that's not exactly something that scientists would do, this kind of cherry picking. But I have two colleagues who told me independently that they repeated these experiments. I don't know that they published, and they concluded objectively that there really is something to it. So that's where we are now, and I'm well connected with the Emoto people. His son Hiro Emoto has taken over for the office Emoto, and there are many outreach efforts that are being conducted by the group, and they're becoming progressively more scientific in their approach. Another one is this guy who's studying information in water, Luc Montagnier, who won a Nobel Prize for HIV. He's now become politically active in the issue of vaccines and such, but let's set that issue aside. But depending on what your belief system or philosophy is. But at any rate, Luke has been busy studying water memory, and he has an experiment whose results are nothing short of amazing, that deal with information and memory. Let me just explain here. Don't be, this is not as daunting as it may seem. So he's got containers A and B. In container A is DNA that is sitting in some buffer, basically water. And next to it, he's got pure water. And these two cannot communicate chemically at all. I put corks here, but obviously these are constrained or contained in more sophisticated way. And so there's no ability of any of the DNA to come into the pure water. Now, to this combination, he adds some kind of generic energy, 50 hertz, 60 hertz, 7.8 hertz, whatever. And he says, this just basically energizes the system. And he says that what's going on is that there's some kind of information exchange from the DNA or the water surrounding the DNA to the water. And in order to demonstrate that, what he takes is he takes this water, B, and he adds it to the precursor material for the PCR reaction. And everybody knows PCR reaction now because of COVID and the COVID tests. And the idea is this produces more DNA, it amplifies. And so you get new DNA. And the surprise is that it matches the DNA that was sitting here. This is amazing because what it means is somehow that the information from here is being indeed transmitted to the pure water. Otherwise, this wouldn't happen.
Now we're getting down to the quantum physics and what they see with quantum physics of things spontaneously appearing, disappearing, and happening in different places. And this is really fascinating.
Well, yeah, some of the people indeed are talking about quantum effects between these. Others are talking about some kind of subtle energy that's going back and forth that may not be related to quantum electrodynamics, which is really what some people are arguing underlies this, but whatever. The point is somehow that the information is getting transmitted somehow over space. You might call this subtle energy, if you will, is what I was talking about a few minutes ago. It could be electromagnetic energy. It could be, it's not well defined. But one thing that's interesting.
I apologize to interrupt you. Have you ever heard of an experiment in the perfume industry where they take their perfume and then they like mix it or dilute it with pure water 50-50, and after repeating this a certain amount of times, it has the same exact concentration as its original mix that they started with. Have you ever heard of it?
Not the same concentration, but the same smell, the same effect, because they are diluting it. Yeah, so you're referring basically to the principle of homeopathy, and which is, taking some substance, usually a botanical substance, and diluting it and shaking it, and diluting it and shaking it. The shaking is important in this. I'm not sure if it's done with the perfume industry, but you can do this again and again and again and again to the point where you have essentially nothing left except water, right? Because at least statistically speaking, only water. And that water has the same impact as the original undiluted specimen. So, and this is what got the water memory issue and people in trouble. It was Jacques Benveniste, who was a distinguished scientist, and he was dealing with a French scientist, microbiologist, and he was dealing with some antibodies, and when he poured the antibodies on certain cells, they would secrete histamine. So antibodies on the cells, they spew out histamine. And someone came to his laboratory in Paris and said, I can do the same experiment and the same result if instead of those antibodies, I take diluted antibodies. So he would dilute, shake, and to the point where, statistically speaking, there's only water left. And the water poured on the cells had the same effect. Histamine would come out. Well, there's a long story associated with this. I'll just quickly summarize, because it got both Jacques Benveniste in trouble and the whole field of water research in trouble, because Jacques used the term water memory, right? Because since the diluted specimen had the same effect as the original antibody solution, it must mean that the water molecules that had been associated with the antibodies must carry information from the antibodies, you see. And he submitted this for publication, submitted it to Nature. And the editor of Nature received it and said, it's impossible. It can't be, because if you're right, everybody else is wrong. And he said, I refuse to think that everybody else is wrong, therefore we're not publishing it. So Jacques, being a canny fellow, and he knew he was right, because the experiment was quite repeatable, not every time, but it was repeatable enough times to be easily statistically significant. So he asked colleagues from a half dozen different countries to repeat his experiment, and they all could confirm the results, and they resubmitted together as a group. The response from John Maddox, the editor, was the same. All of this, by the way, is published. You can find what I'm telling you in books and literature. And Maddox said, I don't care how many people repeat it, can't be right. So it was a little bit difficult. And pretty soon in Paris, which has a lot of homeopaths, they were proud that this famous scientist, Jacques Benveniste, could actually discover a mechanism for what they do clinically on a daily basis. And all this hubbub that appeared in the newspapers in Paris got across the English Channel to the Office of Nature. And Jacques told me when I went to visit him, he said, I got a phone call on this phone right there. You see that phone? John Maddox called me on the phone. He said, I'll make a deal with you. He said, I'll publish it next week in next week's edition. However, the deal is we're going to send a committee of peers to look over your shoulder and, and report back to our readers. So Jacques, thinking, well, that's okay with me. We have a phenomenon here. They're welcome to come. So who was the committee? The committee came 3 or 4 weeks later to Paris. The committee consisted of Maddox himself, who had studied physics, but never quite made it to his terminal degree. And he became a journalist and worked his way up the ladder to be the editor of Nature. The second one was Walter Stewart from the NIH. And Walter Stewart, while he worked there, was a fraud buster. He was interested. If you, for example, claim that the rabbits that you're studying grew these black patches on the white rabbit, and one of your colleagues said, I saw this guy come in the middle of the night and paint those black spots on there, and they couldn't resolve the issue within the university, whether the guy was cheating or not cheating. They'd send it to this special part of NIH, National Institutes of Health, and this guy would be one of the people studying that. So you can sort of get the picture of the committee of peers that were sent. And the third of 3 peers was the amazing Randi. That's James Randi, magician. And
Randy.
You know him.
Wow. Yeah. Oh, of course.
Yeah. Well, a lot of people don't know him. So, he's a really impressive magician who can figure out the tricks of other magicians, highly respected as a magician. And he came too. And so you can kind of understand what the committee was after. They were sure it was a kind of trick, and they assembled the people best able to uncover the trick. Well, finally, they were not able to uncover the trick. But because the experiment didn't work every time, and parenthetically, they reported in their paper that it didn't work every time, but it worked so much of the time that it's way beyond any question of statistical significance. Anyway, when they did the experiment 2 times, everything worked fine. When the committee, Walter Stewart, did the experiment, it failed. And so they huddled in their hotel and they decided this is nonsense. When we do it, it doesn't work. When they do it, it does work. And therefore, it's some kind of trick. Although the amazing Randy was not able to figure out the trick. Well, since then, Benveniste results have been repeated and published by multiple groups. And so there's no question that it's correct, the idea of water memory that he demonstrated. Unfortunately, he passed prematurely, maybe connected or propelled by the difficulty he faced in life, because people would say, oh, you're getting old, you're losing your memory. Why don't you drink some of Benveniste water because it's got memory? You see, as a kind of scientific joke. So anyway, that's roughly. But the story is actually apropos because Luc Montagnier was a friend of Benveniste, and when Benveniste died, he took over and went on to produce results just like this. And I should say that his latest result is if he dilutes this enough times, he told me this, I'm not sure if it's published yet, so that statistically speaking, there's no more DNA, it's just water. He gets the same result.
Could this work with the fertilizer industry? So instead of us using so much fertilizer, we do this process where we put 1,000 parts per million in of whatever, put it into pure water, shake it, keep doing it, shaking it. By the end, can we get the same results with that in water by putting into our plants possibly as if we put 1,000 parts per million in the concentrated?
Brilliant idea. I don't know, but I would say good chance that it could work. Absolutely.
Wow.
Yeah.
Let's get on that.
Well, it is an interesting.
Is there any theories on how long the water could hold the memory? Because I'm just thinking how old some water is, or an asteroid comes in with water on it. Like, has there any theories on how long the memory can actually last after these?
Well, there might be theories. I'm not aware. But theories are one thing and demonstrations are another. So theories are free; anybody can do it, but there's nothing like experimental evidence. The answer is I don't know. I don't. But
I'm just thinking what some of this ancient water could be holding in its memory.
Well,
it's
ancient
fascinating.
Water probably contains a lot of EZ water because people have been studying ancient waters for use as drinking waters. Spring waters, for example.
Right.
And some of these are filled with EZ water. By filled with, I mean a large fraction of those waters are EZ. Others not, but some yes. And
God, just what water holds, and then we treat it, and the processes of how we move water, recycle water, reuse water, just the whole. You think about that, it's got me thinking a little bit differently here now.
Well, I hope so. That's the plan.
Mark, your mic is off.
You're talking about natural springs that comes out of our hills and our mountains where natural water comes out, right? Like
I am, yeah.
And that creates EZ water, like sulfated minerals and springs.
It creates in varying amounts. So
Wow.
we have a way of testing how much, at least qualitatively, how much EZ water is contained in a sample of water. And it's a method that uses the absorption of light at a particular wavelength. And if it absorbs a lot at a wavelength 270 nanometers, if it absorbs a lot, then it's got a lot of EZ water. And if it absorbs a little, it's got a little bit. And if it absorbs not at all, it's got no EZ water. And I've seen reports of people studying various spring waters. and some have not much EZ water, and some have a huge amount of EZ water.
Wow.
And we can understand perhaps why. So surrounding each mineral would be EZ water. And we also found that pressure, if we add pressure, and some of this water is deep down underneath a lot of water and therefore subject to high hydrostatic pressure, that water also, the pressure builds EZ. So if you take this water that's filled with minerals and under high pressure because of all the water sitting above it, it's understandable why it would have a lot of EZ water.
Is this why silt compacts after people drain reservoirs and they can't unpack the silt?
I'm not sure. I haven't thought about that, but yeah, it's yeah, it could be. I have no comment on that, but it's certainly possible. Yeah. Yeah, you're full of interesting questions.
Well, you describe things, and I've watched a lot of people talk about they talk about like the secondary problem or their problem, but they don't talk about the source of the problem. They don't know why the problem is and why they can't fix it. But then when you talk, I'm seeing their problem as in my mind as you're talking.
Oh, it's great. Yeah, you can translate these experiments and theory into practical applications, and that's amazing. I'm impressed. Thank you.
No, thank you, brother.
Okay, well, so let me go on from here. So I tried to demonstrate to you that some kind of memory exists, memory in EZ water. And by the way, this has now been confirmed by a group in Asia, I think from Japan, but maybe it's China, I can't recall, and published. And so it appears it's true. It's astonishing if true. But if we take repetition as evidence for truth, then this apparently is true. Now, a point of relevance is that we think of EZ water as water, as a kind of almost liquid water. It has, based on our measurements, it has the consistency of like egg white, something like this, raw egg white. And so if we think of putting this sort of semi-liquid stuff into a computer memory, it's a little bit awkward. But we found, and others found before us, I'll show you in a moment, that you can actually solidify this liquid crystalline water at room temperature. Now, imagine a kind of liquid substance that becomes a solid, just like ice, but at room temperature. Boggles the mind. And this is a guy who did it first, Vittorio Elia from Naples, an outstanding biochemist interested in EZ water. And he demonstrated, he has a few publications. So this is just a slide from his laboratory. So what he did to achieve these cloud-like structures, he took a piece of Naphion. We use Naphion as a hydrophilic surface very often to get EZ. So his wife, took a sheet of Naphion, and she used a roller to kind of push the EZ water off into another container. And she did this multiple times, and then put it in a unit that's called a lyophilizer, which is a kind of low temperature drying machine to pull off all the free water. And before they put it in the machine, they would take it and put this collected water into a beaker like this. And here is the ordinary water. And here are these clouds that form. And these clouds are presumably the EZ that sticks together in this way, forming clouds. And it's no surprise that this looks like a cloud in the sky, because those clouds.
It does.
Yeah. Okay, so then they take this water and they put it in the freeze dryer. It's used by protein biochemists as standard equipment. And they wind up with something that looks like this at the bottom of the flask. this is a solid, and this is EZ water, solid EZ water at room temperature. And they published it. Whoops. So this is their result. It's a little bit of the solid EZ water at room temperature. And they gave us a whole bunch of it, a small amount of it. And this stuff is probably worth more than platinum because of the amount of time that it takes to produce it. But one of the things that they didn't do carefully is to check to see if this is not the result of some kind of contamination. So we repeated their experiment, and here's what we could find, same sort of substance at the bottom, and we subjected this to tests using a mass spectrometer, and we confirmed, we're just now putting together the manuscript for publication, we confirmed that there is absolutely no contaminant in this that could explain it. This is pure EZ water that becomes a solid at room temperature. Should we wait until it stops ringing?
Sure. This is probably like $50,000 we're looking at right now, right?
I really don't know, but because it depends what people's time is worth.
Now, if you put this back into normal water, it comes as part of the normal water, or does it stay a structured cloud-like substance within that water, or how do you get it back into the state before it became EZ water, which was water?
Well, we just add water.
Just add water, right?
That's all. Yeah, and it dissolves in the water, and it basically becomes the standard water that we had before it was lyophilized, or before it was put into an oven to get rid of the free water.
Have you ever done human consumptions and then how it affects their mental state after?
If you're willing to fund us to conduct studies like that, one of the problems is you've got a laboratory, and the laboratory has a fixed number of square feet, and you've got a budget, and the budget is enough to support 3, 4, 5, 6 people. There's just so much you can do.
100%.
And there are so many experiments that we would love to do, but we have limitations.
Since EZ water excludes everything that's in it, so when you test that, there's no sodium, there's no chloride, there's nothing present, because my mind gets so, when you look at the picture, like, oh, there's a solid, but then when you say, oh, it's EZ water, then it like shuts down, because it's just like, how can that be? So you guys, you do mineral tests as well, like sodium or any other byproducts within that?
Well, we've done some limited testing. It's not so easy to test. It's not so easy to extract the EZ water. It's a challenge. However, we could do it here, but we haven't done that yet.
Got it.
But we're planning to do. It looks as though if you have EZ water and you put salt solution around it, it looks like the EZ excludes that salt, which has some practical application, which I'll show later if I can get to it. Okay. So let me, unless you have any more questions about this, let me go on. For us, this is really exciting that you can, because in terms of information and such, you can presumably impart the information directly to EZ water, and see if the information is there. We think it will be, but we don't know for sure.
Remember, with good information comes bad information too.
Well, yeah. I mean, that is an issue. You could put bad information in there, and it could have some unfortunate impact. So, okay. So again, to conclude this section, you might think in the future of something like this filled with EZ water, and probably solid EZ water in here. We're ways off from doing this, but it could be possible, and if possible, it would make this thing the size of a miniature pinhead. if that could be done.
So the first set of lights I purchased were Enfun, a brand called Enfun. And I actually got 2 sets of those. They were 240 watt light panels, 2 panels equaling 240 watts. And after that, the other ones I purchased was Leno Focus.